Tonight begins with Little Brown Jug's Monarchy English Brown Ale. The tasting notes they offer suggest malt flavors of toffee, chocolate, and dark fruit, with a toffee and toast aroma. So tonight, as no surprise to anybody, I am going to take a look at my my latest acquisition here. This Variac, don't call it a Variac because that's a brand name, this auto transformer, which basically takes AC line voltage and steps it down or up between 0 and 130 volts for a nominal 110 volt input. It's kind of a tricky way that this works, and it's a little bit non-intuitive if you haven't encountered an auto transformer before, but I think I can explain it. But more importantly, I am going to tear into this thing, make sure it's wired safely, and just generally get accustomed to it. So to explain how an auto transformer works, I'll sort of quickly draw it out here. So we'll just draw a normal transformer, pretend those are coils. So we'll put the line in here into there, and depending on the ratio of windings between the primary side and the secondary side of the transformer, you're going to get a lower or higher voltage, or the same voltage, out the other side. If both windings are exactly the same, then you should get exactly the same voltage out, just isolated, right? Or if there's less windings, then you'll get a lower voltage out here. If there's more windings, it'll be a step-up transformer, and you get more output voltage. But if, let's just say this is a 10-to-1 ratio, so this is 12 volts AC coming out the output side. If you common that together, so you've still got 120 volts between those two positions, you've still got 12 volts between there, you're no longer isolated, but if you take your output between there and there, something different will happen. You'll either get 132 volts, 120 plus 12, or depending on which direction these two coils are wound in relationship to each other around the magnetic core, you could be getting 108 volts, 120 minus 12, if you're measuring across those two positions there. So let's try this for a demonstration. We've got 5 ostensibly 9-volt batteries. They're not actually 9 volts because a lot of them are discharged. I didn't have that many good ones kicking around. But we should assume that at the end of this series string here, they should all add together, and we'll have roughly 5 times 9. Well, not quite, because they're not all fully charged, like I said. So 40 volts across all these in series, right? They all add up. But what happens if we take one of them and flip it around? Now, this is going to be a little bit awkward to get them to actually sit there. 25 volts. So what happened? Where did our 40 volts go? Well, because we've taken 7 volts out of the series string, and we put negative 7 volts in. So that's 14 volts minus our 40 gives us 25 and change, right? So that's similar to what I just showed with the transformer diagram. You want to see it in real life with an actual transformer? Here comes the don't try this at home part. Well, one of them anyway. So I've got this cheap little meter on the input side, the primary side of the transformer, and I've got this guy on the secondary side so you can actually see it. So when I power this on, I got 124-ish volts over here and 40 volts on this side of the transformer. So that gives you the ratio of the input to the output. Now then, if I wire this up as an auto transformer, as a non-variable auto transformer, watch what happens. So here's what we've got going on right now. This side of the AC line coming in is still just going straight there. This side of the AC line coming in, the white wires, is going both to the primary and also across to one of the secondary wires, just like I had shown it there. And then there's the other secondary wire going to our meter. And actually, let's plug this guy in. And if we measure across the two secondary wires, we've still got our 40 volts, right? But if I measure across the incoming wire and the other secondary wire, I've got 163 volts, which is our 124-ish plus the, 40 on the secondary side? Now then, if we reverse these so that we're using the other secondary wire, let me just change this around. So now, if we're measuring across there, we're only getting 83 volts, which is, again, 124 minus the 40, right? So that's essentially what this guy is doing, with one exception. It's taking the secondary off a variable wiper. So the winding has, essentially, let me just redraw this just one moment. So what's happening in the auto transformer, we still have this configuration here, except for it's mechanically laid out a little bit differently. Still have our primary, still have our magnetic core, but the secondary is physically located there. So they're not separated. They're still wrapped around the same magnetic core. They're still an inductor. So we got 120 volts there, and on the example I was using over here, 12 volts. So, and then across there, we've got, what did I say, 132? So, in this configuration, if we move this connection here somewhere else, if we move it, say, to the middle of there, we'll only be getting, 120 plus, say, 6 volts, right? If we move it to there, we're getting 120 minus whatever this percentage is, so we're getting like 5 or 6 or whatever volts out of it. Because it's not acting like a resistive voltage divider, it's not acting like a potentiometer. The inductor and the magnetic core are interacting here, and it's acting just as if you had you were using this tap out here. It's a little bit magic, but I hope it makes sense when I explain it like that. If not, I'll link to the Wikipedia article about auto transformers down below. Anyways, that's enough theory. Let's clear the bench and start taking this thing apart and just make sure it's safe to use. Probably the first and easiest thing to check is the ground there? Yeah, it is. Okay, that's good. Is the chassis grounded? Yes. Oh, that's a good sign. Okay, well, let's start playing screwdriver games then. I'm going to assume that this little front control panel-y thing comes off, in as much as it's got screws holding it together. I don't know what intelligence it'll show us. They feel like they're really long screws. Yes. Ooh. Looks like it was tapping its own threads. There's some filings and crap on there. Hello. So there are no crimp terminals. It's all soldered directly. That's not horribly offensive in and of itself. Cables coming in with, the strain relief of champions, hot glue. Interesting. And the output is also mounted with hot glue. That's not highly inspiring, but it's also not entirely surprising. And the meter's mounted with hot glue too, sure. That's just kind of flagged on there. That's pretty gross. There's, well, I guess none of the leads are flying too loose, and the strands, they're all kind of blobbed in solder there. Less than ideal, but at least it's solid and firm. Would have liked to see some heat shrink on it. I'd like to see a little bit less burn on those wires, but we'll live with it. Yeah, let's put those meter wires so that they're not touching, because those are live at the output voltage. It would have been nice to see some heat shrink on these. Would have been nice, good form, if they had actually poked the wires through the holes before they soldered them. Oh well. Over here on the case, I'm going to have to pull the knob off, and I will. Oh, that's not really strain relief. That's just kind of. There is one. You can feel it, 2, 3, 4 screws around the perimeter there, and I also have to take the knob off the top too, which, for reasons unexplained, uses flat blade screwdriver. Not a huge fan of that, but a little captive nuts in there. Okay, that does the job, I guess. Big old knurled shaft here. Not really centered, but you know, so be it. That's cosmetic. Anyways, I'll undo these screws, and then I'm guessing that lifts the cowling off so we can see underneath the hood here. Roll that guy back on his feet, and up she comes. That comes off easily. Kind of nicely painted. These screws aren't super inspiring because they're not really self-tapping screws, but they're kind of tapped into the sheet metal underneath there, and the heads aren't really that big compared to the slots, but whatever. Was that flopping in the breeze before? Oh, that was probably underneath one of those, wasn't it? Okay, yeah. So here we go. So here's the movable element, and it's got a couple of screws just holding it onto the shaft. I'm just going to make sure those are tight, properly tight. Seem to be. That one's already got some kind of sharp and shiny bits in it, so whoever was tightening that at the factory cammed out a little bit. All right. But here you can see the 2 wires coming in from the front here. So we have the blue wire going through the switch. Oh, that's an illuminated switch. Okay, that's why it's got both sides going to it. Huh, I was concerned there for a minute. Okay, so we have this wire here. I guess based on EU color code, that would probably be brown, I'm guessing, with my colorblind eyes. Goes through the fuse to the switch, out of the switch to this tap position on the transformer, on the auto transformer. And then the other side, the blue wire goes through the black wire down here and to the black wire there. So let's call that the 0 volt end, and let's call this the 120 volt input end. So that is how we're able to get a higher output voltage, because if the wiper's right there, and that the wiper feeds to the yellow voltage and out the hot side of the plug here, right, socket. So if we're right there, we should be getting exactly the same in and out. But if we come past that, then we are into this portion of the auto transformer here, and we are going above input voltage. And anywhere over here, we are going below input voltage. So over there, is that about halfway between there and there? Sure, that should be about half of the input voltage over there. This wiper here is a little carbon brush that's just spring-loaded. Yep, spring-loaded against that. So it wipes against the flat surface here where the enamel insulation has been sanded off. And that picks up the voltage from wherever, transfers it over to there. Let's just, yeah, that's tight. Yeah, everything seems to be, oh, that's a little bit loose, but that's just mechanical. Okay, so that'll be the mechanical bit that's holding this little heat sinky piece onto the plasticky non-conductive bit. So why is that heat sink? Because a carbon brush is going to be a little bit resistive. When you've got resistance and power going through it, you've got heat. So that's what that little heat sink is there about. The yellow output wire makes a couple of laps around the center there so that it can coil and uncoil without being horribly stressed. And it's sort of held there, but not too firmly. Okay. All in all, I mean, below average soldering aside, it's still held together. It's still doing its job. I'm going to call that safe enough. Now let's put it all back together. Let's plug it in and see what happens. Nothing bad, okay. Turn it on. That lights up. That's good. Right now I got it set down to 0 volts, and actually, so right now it's just, this thing thinks it's just seeing a resistance, which it is, it's just seeing the coil. As soon as I start bringing this knob up, I got 5 volts AC, 6, 15, I'm going to aim that at the 30, 34, so this dial isn't super calibrated up here. What's that guy saying? Saying it's somewhere between 25 and 50. Okay. So let's bring this up to 50 because that's the next tick mark. I'm not expecting this meter or that dial up there to be perfectly calibrated. That says 45. The real meter says 50. That one's bouncing around just above 50. Okay. I wasn't expecting that to be accurate anyways. Let's see where 100 is. Remember, 120 should be, oh, you can actually see the tap right there. So 120 should be right around there, or the input voltage, basically. It's 124. I think that's what we said the input voltage was before. It's about 124, right? Here it's saying 115, but this thing's expecting 110 input, which is, I guess, what the 100-ish volt standard is in China. Here in North America, it's closer to 125 for normal. So that being the same, I should be able to get a little bit more than 130 out of this if I peg it. 141, 144. Okay. That's nice. I don't know how much I'm going to use that to overvolt things, torture test things, but right in around, yeah, that's pointing at the 100 volts. So 107. Let's just pull this right down to 100 even. That's showing just a hair under 110. That's just a suggestion. And maybe I'm going to try and find a little digital meter that I can put in there, a little digital AC meter. If I can find one, I don't know. Look around eBay, see what I can find. Maybe. You never know. Anyway, that's the basics of how it works. Did I answer the why? No, I didn't. So this style here, with the plug-in on them, the benchtop type, tend to be used as test equipment, especially in equipment that has linear power supplies, not switching power supplies. That's the main use, so that if you don't trust your linear power supply, you can just bring it up slowly and watch the output without exploding any capacitors or anything. That's the primary use for these. Guys that work on tube amplifiers use them quite a bit, just because, again, for the same thing, you can sort of soft start it and make sure that you're not going to blow anything out. And watch for the voltages in your circuit to make sure they're not getting way out of hand or outside of normals. So that's my application for this one. Although realistically, I don't do a lot of that kind of work anymore, but I always wanted one. And thanks to the generosity of my Patreon supporters and those of you who don't have ad block turned on, I was able to buy one. So that's cool. Where else are these variable transformers, aka Variac, but again, that's a brand name, where are they used? Let's go to the interweb and find out. Turns out that they are used in quite a number of industries. Partly just to adjust the input voltage thing. You can use them as a speed control on a motor, for instance. You can use them for dimming a lighting load, for instance. It's not done that way very much anymore, but there are a wide variety of this kind of beast available. Here's the sort of portable desktop version for test bench, like what I've got in 120 and 240 volt modes. There are single phase and 3-phase versions available. Oh, there's the other thing too. You can have them that they step up way up. So that's basically a tripling, right? 240, 480. Yeah, that's, well, 2.5 anyway. But the other place that these variable auto transformers get a lot of use is in industry, where you need to maintain a stable output voltage, where you don't trust your input voltage source to be stable. Back when I was working in broadcast, we had one very similar to this, although it wasn't made by a Chinese company. It was made by a Canadian company who doesn't make this kind of thing anymore. Anyway, we used this kind of beast on our transmitters because they are often located in rural areas where you can get cheap land, and rural areas notoriously have unstable power. And Buddy Farmer down the road fires up his feed mill, and it drags the whole 3-phase line down to like 180 volts instead of the 240 it's supposed to be. So you have the power comes in through these 3 filtering inductors basically, and then through the not a variac, stop calling it that, through the auto transformer. Each one of these auto transformers, though, has a motor controlling it, a servo motor, in a closed-loop control configuration with the electronics in the cabinet, which are monitoring the output voltage and trying to keep it at the nominal voltage, whatever you've configured it for. So on our broadcast transmitters, they would vary the current draw based on how hard the modulation was hitting, which is basically how loud the music was. So these things would be dancing more or less in time with the music, just by a couple of volts though. But again, where you'd really see them kick in is when the farmers down the power line from us would kick on some big 3-phase motors and cause the entire line to sag. And these things pick up fairly quickly and keep the transmitter happy. So that was a good little exploration. Refreshed my memory on how an auto transformer works and the variable style. Made sure that this one is reasonably safe to use, and yeah, I hope that was interesting or informative or something for you guys. Questions and comments down below in the comment section as usual. Thanks for watching. I'll talk to you later.